In 2026, NASA will launch a telescope so powerful it can photograph 100 million galaxies in a single image. Not over weeks, not over months, in one exposure. The telescope is called the Nancy Grace Roman Space Telescope, and what it is designed to see is not just distant galaxies or alien planets. It is designed to see time itself, specifically the moment when the universe started tearing itself apart. That tearing is still happening, right now, accelerating, and we have no idea why. Here is what is actually going up there. The Roman telescope has a mirror 7.9 feet across, the same size as the Hubble Space Telescope. But that is where the similarity ends. Hubble's camera sees a patch of sky about the size of a grain of sand held at arm's length. Roman's camera sees a patch 200 times larger. In a single snapshot, it captures an area equivalent to 100 Hubble images stitched together. That field of view changes everything. Hubble spent decades building its deep field image, staring at one tiny corner of the universe for weeks to collect enough light. Roman can do that in hours, and it will do it thousands of times, mapping the entire sky in a survey that would take Hubble 500 years to complete. The telescope will not orbit Earth the way Hubble does. It will sit at a gravitational balance point called Lagrange point 2, 1 million miles from Earth, in the opposite direction of the Sun. At L2, the combined gravity of Earth and the Sun creates a stable pocket where a spacecraft can hold position with minimal fuel. The James Webb Space Telescope is already there. Roman will join it. And from that vantage point, shielded from the sun's glare and Earth's heat, it will begin the largest astronomical survey ever attempted. The primary mission is called the High Latitude Wide Area Survey. Over 5 years, Roman will photograph billions of galaxies across a third of the entire sky. Not random galaxies, specific ones. Galaxies whose light has been traveling toward us for 11 billion years. That light left those galaxies when the universe was only 2.7 billion years old, less than 20% of its current age. What Roman photographs is not what those galaxies look like now. It is what they looked like then. The telescope is a time machine that works by default. The farther you look into space, the further back in time you see. But distance alone is not enough. Roman is looking for a pattern, a distortion in how those galaxies are distributed across space. That distortion is caused by something invisible, something that makes up 68% of the universe but has never been directly detected. It is called dark energy, and it is ripping the universe apart. In 1998, 2 independent teams of astronomers made a discovery that overturned cosmology. They were measuring the brightness of distant supernovae to calculate how fast the universe was expanding. The assumption was that gravity should be slowing the expansion down over time. The data showed the opposite. The expansion was speeding up. Galaxies were accelerating away from each other. Something was pushing them, not from outside, from inside the fabric of space itself. They called it dark energy because they had no idea what it was. And 28 years later, we still do not. Dark energy does not pull. It does not attract. it pushes. The more space there is, the more dark energy there is. As the universe expands, dark energy grows stronger, and that creates a feedback loop. More space means more dark energy. More dark energy means faster expansion. Faster expansion creates more space. The cycle compounds. Eventually, billions of years from now, the expansion will accelerate so violently that galaxies will be ripped apart. Then stars. Then planets. Then atoms. The universe will not collapse. It will disintegrate. And Roman is going to measure exactly how fast that is happening. The method is called baryon acoustic oscillations. In the first 380,000 years after the Big Bang, the universe was a plasma so hot that light could not travel through it. Sound waves propagated instead, rippling outward from density fluctuations in that primordial soup. When the universe cooled enough for atoms to form, those sound waves froze in place. They became a pattern imprinted on the distribution of matter. Galaxies formed preferentially at the peaks of those frozen waves. And that pattern is still visible today. If you map enough galaxies, you can see it. A slight clustering at a specific distance scale, roughly 500 million light-years across. That is the ruler, the cosmic yardstick. By measuring how that clustering has changed over billions of years, Roman can calculate how fast the universe was expanding at different points in history. If dark energy is constant, the expansion rate will follow a predictable curve. If dark energy is changing, the curve will deviate. And if dark energy is not energy at all, but a flaw in Einstein's equations, the deviation will follow a completely different pattern. Roman will tell us which one is true, but the mission does not stop there. The same wide-field camera that maps dark energy will simultaneously conduct the largest exoplanet survey in history. Roman will stare at the galactic bulge, the dense core of the Milky Way, and monitor hundreds of millions of stars at once. When a planet passes in front of a background star, the star's gravity bends and magnifies the light from an even more distant star behind it. That magnification creates a temporary brightness spike called a gravitational microlensing event. If the foreground star has a planet, that planet creates a second, smaller spike. By watching millions of stars continuously, Roman will detect planets that no other telescope can see. Cold planets, distant planets, rogue planets drifting through interstellar space with no star at all. The telescope carries a coronagraph, an instrument designed to block the light from a star, so the faint glow of planets orbiting it becomes visible. It is a technology demonstration for future missions. If it works, Roman will directly image gas giant planets around nearby stars. Not just detect them, photograph them. And in those photographs, scientists will analyze the spectrum of light reflecting off their atmospheres, searching for chemical signatures that might hint at whether similar techniques could one day find life. And here is the part that makes this different from every space telescope before it. Roman was designed from the beginning to share its data immediately. No exclusive access periods, no delayed releases. Every image Roman takes will be uploaded to public archives within days. Anyone will be able to download them. Students, researchers, amateurs. The entire Sky Survey will be open source. That has never happened before at this scale. And it means discoveries will not come from a single team analyzing proprietary data in secret. They will come from thousands of people examining the same images from different angles, asking questions no one planned for. The launch is scheduled for May 2027. The mission will last 5 years, possibly longer if the spacecraft remains healthy. And when it is done, humanity will have a map of 100 million galaxies spread across 11 billion years of cosmic history, showing exactly how fast the universe is destroying itself. We will know whether dark energy is a cosmological constant, a dynamic field, or evidence that general relativity breaks down at the largest scales. We will know how many Earth-like worlds exist in our galaxy, and we will have photographs of planets orbiting other stars, resolved well enough to see weather patterns in their clouds. The universe has been expanding for 13.8 billion years. For most of that time, gravity was winning, pulling things together, building galaxies, forming stars, creating the structure we see. About 5 billion years ago, something changed. Dark energy took over, and now the universe is being torn apart faster every second. Roman will not stop it, but it will show us exactly what we are watching happen. And that might be the most unsettling discovery of all. The countdown has already started. The telescope is real. The data is coming. And in 2027, we will finally see what the universe has been doing while we were not looking.